Okay, so let's briefly discuss something about statistics. Okay, so statistics, I have already told you, probability is incomplete without statistics. Yes, if we don't know how many numbers are there on a die, then how can we can write the set S of sample space, and then how come we can predict the probability? So first of all, you should be able to know what is the data regarding the particular experiment, and that data is represented in the form of statistics only. Okay, so where there are various statistical methods, and what is basically statistics is that it deals with the collection. How do you collect the data? Then classification means how do you classify or write the data. If you write that data in a tabular form, or if you write the data in a graphical form, all those are known as classification. And then how do you analyze data? That means, do you want to find out the average? Do you want to find out the mode? Do you want to find out the deviation between the two data points, etc.? So all these things are included in your statistics part. What all things? Collection, classification and analysis of the data, from which you can draw some thoughtful conclusions. Like, you know that in an exam some students are, like for GATE also, you are appearing for GATE exam, then we have one data which is given by the total number of students and the appearing the GATE exam. Then we have some normalized score, then we have some rank, then we have some other data. So all those data are nothing but your statistics only. Now for collection of data, what do? We can't do check the data for each and every people. Like for the census, population census also, the government does not come to each and every individual and ask about their age, birth date and so on. What do? They just ask one important person of that family who can like tell about everything about all of the other persons. That's what they do. So if you go to each and every individual of a population to ask regarding their data, then it will be very time-taking task. So what do? We do sampling. Sampling means, like, if I want to ask that what is your opinion regarding my teaching, if I want to ask, if I go on asking to each and every individual, then it will take a lot of time. But if only 2 or 3 people also reply, then I can get that yes, something is going bad or something is going good. Yes. So this is how we will do the collection of data. Collection of data is done during sampling only. We will not go to each and every individual. We will just take some random group, and then we will just consider their data as the behavior of your population. Now obviously, due to this sampling, the exact data will not be obtained. There will be always some error due to the sampling. So if you want to select a good sample, that means the sample size should be very much appropriate, so that the error will be very, very less. So always the sampling will generate into the error. Okay. So this is about the collection of data. Now let's come to the classification of data. So first of all, write down all the points. First of all, write down these points from the slides. Actually, these are not important things, but yeah, 1 or 2 times this has been asked in the exam. So please write it down. Okay, so I guess all of you have written it down. So when you have done the collection of the data, then what will you do? You will classify the data. Now I have told you that classification can be done in 2 ways, either in the tabular form like this, as shown in your slide, or in a graphical format. Okay. So this is the tabular form that you can see in your slide. No need to copy it. Okay, we are just understanding the terms over here. No need to copying it down. So we can see that this is some data. So let's say this class denotes your marks in a particular exam. Class denotes your marks in a particular exam. So frequency will denote your number of students getting those particular marks. Yes. So we can, like, if the total marks was 50 marks, so I can divide this 50 marks into some classes like this, that 0 to 10, 10 to 20 and so on, and then I can find out how many students are falling into which particular age, and that will be known as its frequency. Okay, so you can see that the 0 to 10 marks, 2 students are getting 0 to 10 marks, while 40 to 50 marks are also got by 2 students. Now what is cumulative frequency? What is cumulative frequency? Do you understand what is cumulative frequency? Cumulative frequency takes the effect of the all past data. That means if for this data it was 2, 10, 5 and 6 and 2. So for this cumulative frequency, because there is no past data, it will be 2. For this class, the cumulative frequency considering the past effect is 10 plus 2, that is 12. For this one, it will be 2 plus 10 plus 5. Consider all the previous data like this. So what is the cumulative frequency? It is nothing but the effect of all the previous data. Like you are completed with your 2 subjects, or you will be completed with your 2 subjects after engineering mathematics. Then what you will do? Right now you should be solving the questions from general aptitude. But after completion of my subject, you will be solving the questions of general aptitude plus engineering mathematics. And when the third subject is complete, you should be solving simultaneously the questions of general aptitude, mathematics and that third subject. Yes, that is what the cumulative effect is. Okay. So that is about cumulative frequency. But where this cumulative frequency is used, means this class is denoting marks, this frequency is denoting the number of students, but what is denoted by this cumulative frequency? So if I say that the 20 was the cutoff marks for this test, 20 was the cutoff marks for this test, then what you can see is that from cumulative frequency you can directly determine how many of you or how many of the students failed this exam. If the cutoff marks is 20, you can see that for the second class, that is 10 to 20, your students are 12. Means 12 are the students which are getting lesser than 20 marks. So you can directly say that the 50 minus 12 students have passed the exam. So this is where the cumulative frequency comes into play. It helps you in determining some level, that below this level how many students are failing, after this level how many students are failing. Okay, so this is the use of cumulative frequency. Now again, this is the tabular format. I can write this data into graphical format also, and because this is a classified data in which I have classes like 0 to 10, 10 to 20 and so on, I can be able to draw the graph something like this. No need to write it down. Okay, so if I denote this as x and this as frequency, then you can say that for 0 to 2 it will be 2, for 10 to 20 it will be some 10, and so on. You will be drawing some graphs like this. Okay, so this kind of representation is the graphical representation, and it is known as histogram. Or do you remember? It is known as histogram or bar graph. So this is the graphical representation of your data. Now one thing is, if your data is numerous means, yes. So if your data is numerous means your data range that I have taken is just, let's say, 0 to 1 mark, 1 to 2 mark and so on. Then what will happen? Your graph which was bar graph now will be becoming something like this. It will be a combination of infinite points, and if you join all those points, then the graph will turn into a curve. When the graph will turn into a curve, when your classes have a very small range, then your bar graph will turn into a curve which is known as frequency curve. It is again the same thing, x versus f graph, but now because it's a smooth curve, it is known as frequency curve. Okay, so now we have seen frequency distribution. Now there are some characteristics by which we define several frequency curves. Like for an example, if I draw some frequency curves on the graph like this. Okay, first of all, just write down this classic characteristics of frequency distribution and then draw the graphs that I am drawing. So there are some characteristics of this frequency distribution. You can see I have drawn several frequency curves. all these curves have x-axis as x and y-axis as frequency. Now you can directly observe that there is a difference in each and every of the graph. Like if I see A part, A graph, then its peak occur at some particular value of x, let's say xi, which is less than this particular value of x, let's say xi dash. So you can see that for the graph B, or I'll write like this, xia, xib. So for the graph B, the value of the peak occurs at a larger distance as compared to the graph A. So what is that peak denoting you? That peak is known as the measure of central tendency, which is the first one in your slide. What is central tendency? It is a point around which all your data is distributed. You can see that it's a central point around which my data is distributed. Now obviously there is a difference between these two, that central tendency point is lesser as compared to this value for the graph A. Yes? So this is the first characteristic by which we can differentiate between two frequency distributions, and that is known as measure of central tendency. And what is measure of central tendency? It is the value about which your data is distributed. Now again let's have a look over here. Okay, now in these two graphs, in the graphs of C and D, XIC and XID, the measures of central tendency for these two graphs are approximately the same. You can say that the measures of central tendency of these two graphs are approximately the same, but still there is a difference between these two graphs. And if I ask you what is the difference, then you will say that, ma'am, this graph is like closely packed and this graph is widely spread. This graph is spread from this x1 value to x2 value, while this value of x1 and x2 is very, very less. Yes or no? So this difference means the spread in the amount of your data is denoted by your second characteristic, which is your measure of dispersion. What is measure of dispersion? Measure of dispersion is some quantity which denotes the spread in your data. Like in this case, measures of central tendency is not enough to distinguish the two frequency curves. If you want to distinguish them, then instead of these also you need the measures of dispersion so that you can define them properly. Okay, so these are known as measures of dispersion, which denote how the data is spread around your central value. Now let's come to E and F. Now what is the difference over here? Now the graph is not symmetrical in the cases of E and F. These are not symmetrical about your central value as in the case of all these things. So again there is some distinguishedness that you want to ask. Okay, only defining the dispersion or only defining the central tendency will not have a great effect on distinguishing the graph. You also need that how the data is shifted from its central value. This kind of measure is known as measures of skewness. What does it denote? It denotes the degree of asymmetry in your graph. These all are symmetrical, but these two are not, and this asymmetricity is denoted by using the measures of skewness. Okay, so that is why if you want to define a particular graph, so you need all the three things: measures of central tendency, measures of dispersion, and measure of skewness. Okay, so this is about the characteristics of frequency distribution. We will write about them in the next class. Okay, it's not very difficult to understand, just basic quantities that we need to understand. Measures of skewness. So measures of skewness denotes the amount of asymmetricity in your graph is present. You can see that this graph is symmetrical about this line, while this graph is not symmetrical about any line. So there is an asymmetry in the graph, and that asymmetry is denoted by the measures of skewness. Okay, that is the measure of skewness. Any other doubts? So we will write all these things in the coming class. Skewness basically means inclined. Skewed means inclined. So this graph is inclined towards left side, towards right side. So we can say that this graph is skewed. While these all are not skewed. So good night all of you. We'll meet again tomorrow.